Welcome back to the Code Ryan podcast. Today, Radu joins me and we're going to discuss machine learning, how he got into it, and we're also going to discuss how machine learning might apply to developers and people using JavaScript and different things like that as well. But before we kind of get to those topics, Radu, could you maybe give me a brief background on kind of your tech journey so far and how you kind of got into machine learning?
Yeah, sure. So I got interested in computer science and computers in general when I was in high school. And my first job was actually as a Flash developer. So I was doing Flash ActionScript, and that was something like 2009, 2010, so quite a long time ago. And since then, Flash kind of disappeared. But of course, a lot of the things you learn there are quite valuable in any technology that you use because it can be applied in other things as well. And then I moved from Romania, where I was born, to Finland, and I did my master's studies here and my PhD. And already during the master's, I started being part of the machine learning group, research group at the University of Eastern Finland. And it wasn't called the machine learning group back then because there was no machine learning back then. I mean, machine learning is basically this kind of buzzword that started appearing at some point. And eventually our group was renamed to that, but I was doing it all along. We just didn't know it is what we are doing because the concept didn't exist. And or maybe it existed, but it wasn't that well-known or widespread. And then I also went to Microsoft for a bit. I was there also doing machine learning things, so more of a research role than a developer role. And yeah, after that, I came back here and I stopped doing research. Actually, at the moment, I'm just teaching. But of course, machine learning is one of the topics that I teach.
Gotcha. So kind of went a little bit of the academic and research route with machine learning. And is there a reason that you kind of wanted to go kind of that route rather than maybe getting more into the development side of things or working as like a machine learning developer? Were you just a little bit more kind of drawn to maybe the academic and teaching route?
It's much less stressful and much more flexible and longer holidays and more time for yourself. But I was doing development all the time, but instead of working for some company, I was implementing my own ideas or my colleagues' ideas. We were working in a team. And I think one of the main reasons is that I always got the opportunity to do what I wanted to do. Like I was getting funding to do my PhD, and then after that I had a postdoc for a while. And I did get to see also this kind of corporate world. Like when working in Microsoft, I got a pretty good idea, even though I was there just briefly for about for 6 months. But I did get an idea of how that kind of world would be. And the reason is just convenience. And now I'm mostly teaching, which is really nice when you have a small kid at home, because research and other things tend to follow you home and make your mind preoccupied with those things. It can be a problem depending on your life and what you're doing at the moment.
Yeah, absolutely. I currently work remotely at my current job, and it can be good and bad. Like, it's very nice that I don't have to have that commute to work, but that kind of catch-22 is work is always at home as well. So I don't really have that distinction between home and work, which can be a little bit tricky, and it kind of makes you more responsible to make sure that there is that distinction and you're not kind of letting your work bleed into too many kind of other things there. But that's really cool. It sounds like you kind of saw that with kind of teaching and kind of going the more academia route, that led to just a better lifestyle for you and led to a better kind of schedule. You can work on your own things and kind of suited you better there. But now to transition into machine learning and how that applies to developers and different things like that, maybe let's just start with what is machine learning? Like you kind of mentioned that it is kind of just like a buzzword. So how would you kind of describe what machine learning is?
Well, it's all about the data. So what you start to learn in computer science when you start going into the field is how to write code, how to write if statements, for loops and things like that. And machine learning is just a way that you avoid doing that and you let the computer pretty much figure out what those if statements should be based on a bunch of data that you have collected somewhere, and hopefully it's labeled data, and hopefully it's also clean data. It's something that you can trust. So then computers can use algorithms built on some mathematical models that make these decisions for you. And they are educated guesses because they are using a lot of historical information to draw these conclusions. So if you think that you could program an algorithm that solves a specific problem, you may not know all the variables. How to say? Like, let's say that you want to predict how much an apartment costs, and you have variables like where it is. Is it in the city center or is it somewhere in the peripheral? How big the surface area is, how large the surface area is. Those are variables that play a key role. And there may be many more things like that, like how high up is it, and do you have a nice view, and things like that. Maybe construction year. Newer buildings are going to be more expensive. How do you write the if statements for something like this to decide how much it should cost? The formula that you want to implement there is not trivial. But with machine learning, you can have the computer figure out what the price should be based on a bunch of data, like a huge collection of apartments and their properties and how much they were valued at and sold for and things like that. So that's really what it is doing in essence. It's making more powerful applications that are more capable, more accurate, because they have been trained on data.
Gotcha. So in your example there, Ed, I am like a machine learning idiot as well as artificial intelligence. Like I'm mostly a web developer, just kind of dipping my toe into this stuff. So if anything I say is stupid, just let me know. But so for your example there, so it sounds like what you might do in a machine learning application is you would potentially provide a ton of different data points of a ton of different like apartment prices in a bunch of different cities with a bunch of different square footage, and just provide them all this data. And then it might be able to make a prediction of, okay, I have all this data of all these different apartments, of all these different prices, of all this different square footage, and all these different conditions, 2-bedroom, 3-bedroom, so on and so forth. And writing just like a basic, if statement algorithm for that would be, almost undoable. Like it would be really, really difficult to write.
You can do it
every single condition.
You can do it if you keep just one or two variables. I think it's quite easy. You figure out what should be there. But so many other variables come into play. Maybe even how many past owners it have, who was the past owner, or these kind of things. So many small things can play a significant role, and it becomes basically impossible. And it helps to use machine learning in this context.
Absolutely. And then machine learning would potentially be able to predict, okay, if you, maybe asked it a question or had something to where it's like, okay, now what would be the rent for this city with this location, this square footage, and, so on and so forth. It might be able to, say, okay, based on all this other data, it might be something like this. So does that sound like about right there?
Yes, it does.
Awesome. And also potentially a stupid question, but what is the difference between machine learning and artificial intelligence? Like, I think both of these words are very kind of popular. Both might be classified as buzzwords these days. What's kind of the distinction between the two? Is there a distinction? Like, I think it could get like a little bit murky for me on maybe what the like actual difference between machine learning and artificial intelligence is.
Machine learning is this kind of a new word. At least I don't think it has been popular for a very, very long time, but artificial intelligence has been popular for a very long time. Like maybe 50 years ago or so, people have been talking about artificial intelligence. And what it meant then was that computers are able to act intelligently and solve some problems in a very nice way. For example, playing chess or routing you to your destination. Like when you use Google Maps or Apple Maps or whatever to get your path, those have been classified as artificial intelligence. For example, this pathfinding algorithm. And that doesn't have to do much with machine learning, if you think about it, because we are not feeding data into it so that the computer draws conclusions from it. You would think that AI and machine learning are separate things. But nowadays, machine learning is considered part of this artificial intelligence to some extent. It's a little bit strange, but anyway. So AI is any kind of solution that implemented on a machine is going to answer some questions or solve a problem in a similar way that humans do. Like, for example, this one, figuring out how to go from point A to point B. You could spend the time with the map as a human and figure out the path to go, or you can let the computer do it for you. There was a time when you had to spend the time with the map and figure out. But that doesn't have machine learning in it. So AI encompasses more than just machine learning. And also, if you think about machine learning, I don't really agree that it's necessarily part of AI, because you could use machine learning to do something relatively simple. Like the example I gave previously with the apartments, this really becomes just a simple equation in the end, like a formula for how to calculate the price or the rent of an apartment based on all these factors. It just becomes a formula. Like maybe you take the square footage, multiply it by something, add the how many years it has existed for and multiply that by something and so on. Or maybe subtract that because you want to lower the price the older it is. But anyway, it becomes a formula. And is that really acting intelligently? I mean, any combination of those variables that you put in, it's going to put them in the formula and say, this is going to be the price. The formula itself is derived from a bunch of historical data, and it's probably going to give some very smart answer, but it's still just one formula after you're done with the training part. So, I don't know. I think that some machine learning is not necessarily doing an intelligent task. It's just plugging in some values in a formula, and that's it. So, yeah, machine learning learned on data. So computer behaves in a certain way because it has studied data. AI, for example, that routing from A to B or playing chess, you don't necessarily need to have studied past games of chess to be able to make a computer that can play chess to some extent. You just have to study the rules of chess. So, yeah, I'm not sure if the explanations were good, but that's my view on the topic, and you will find a bunch of different views on it.
Gotcha. And yeah, I think that does, generally clear it up more for me. It sounds like, machine learning in some aspects, it might be a part of artificial intelligence, but in other aspects, there's potential machine learning tasks that aren't really necessarily artificial intelligence. And there's also artificial intelligence, like solutions that might not necessarily use machine learning. So they're not necessarily like always used for one another, but you can potentially use machine learning for certain artificial intelligence applications. Does that sound fair?
Exactly. And one more example, I did mention in a way that machine learning, what basically it does is that it figures out how to put those if statements and make a mathematical model for doing something like predicting something. In principle, a human could do that if they spend like many years writing those if statements. So if you do manually implement a system that behaves intelligently without the use of data, you just made an AI without machine learning. So by hand, basically. But it's not the way people do it now, because we have a lot of statistical tools that can really help you get something much better.
And I definitely wouldn't want to be the one in charge of doing all that by hand either. So that would be pretty brutal.
Yeah, it would. In practice, there are not just 1, 2, 3 variables, like in my example. There can be hundreds, thousands. There can be hundreds of thousands of different variables into these scenarios. Like if you think about computer vision, like tasks that are solved using a camera, maybe like navigating on the road, self-driving cars, things like that, or face recognition, things like this. What you usually feed into the input is each individual pixel of the image. So depending on the resolution of your image, you may have millions of pixels. Usually they use lower resolution images because even if the image is not that high quality, you can understand what is there, and it lowers the complexity of the model. But each individual pixel in an image like this is basically equivalent to the square footage, the years that it existed, and so on. Each pixel has its own contribution into figuring out what that thing is. Is it a handwritten digit? Is it somebody's face? Is it a stop sign outside? So it becomes really impossible to make if statements with each individual pixel by hand.
Yeah, that would not be a good time whatsoever. Would it be a good time to just do it for one single frame? And I can't imagine like what the effort would be like for multiple frames over the course of, an hour-long drive or an hour-long video or something like that. Like that would be pretty impossible, honestly.
What has happened meanwhile is actually people are not writing the decisions like is this a stop sign or not in code. But what many people have to do in these applications is make sure that the training data is of high quality and that it's labeled. So you may have a team of machine learning experts, engineers, who are just labeling data, like highlighting this is a stop sign, this is a yield sign, this is a crossroad, and whatever things are, because that's how the system learns as well. It needs to know what is correct and what is incorrect to be able to draw those conclusions. So a lot of effort and human effort goes into labeling things. Like if you want to recognize handwritten digits, you give to a bunch of people a bunch of handwritten digits and say, what is this? Is this a 6? Is this a 7? Is it so on? And then you have a collection of a bunch of these with true labels, and your system has to figure out the relationships between each individual pixel in the image and the label that you say is correct or incorrect. And that is, unfortunately, a lot of manual work. And somebody, a human has to do it because you want the machine to reply in a human way. So
yeah, that also doesn't sound like my favorite type of work, but thankfully there are people willing to kind of do that. And I think maybe I read somewhere that for Tesla that they were hiring like a large number of just people doing exactly what you just said, just doing kind of that labeling aspect of things, which is definitely a kind of manual step in this process that is tedious, but sounds like it's needed to kind of get the result we're looking for.
Yeah, same went also for ChatGPT. they also needed to filter out what are correct answers to things, what are incorrect answers to things. And the job is not easy. I think it's been even controversial situation because people are exposed to all kind of information from the internet. So you may be looking at sensitive content and things that you wouldn't want to be looking at. And it's a job that, a lot of human hours has to go into it, and a lot of it is unfiltered like that. So you don't know what to expect.
Yeah, I can imagine there would definitely be some unsavory things that would come across the screen that you have to kind of go through and label as it's kind of part of the gig. So kind of with that, Radu, what applications do you see for machine learning for web developers? Like, are there any just maybe like cool things that you've seen are done, or any areas that you think a web developer, like, hey, this is pretty cool, maybe they should kind of know about this certain application? Or is there anything that kind of comes to mind for you there?
If you think about web development, much of it is only partly done in JavaScript, in the sense that half of web development is the backend side. And basically, if you're a front-end web developer, you could connect to any kind of backend service that you can imagine through their APIs or whatever. Maybe it's on your own server. And essentially, when I think about it like that, then applications for web development are endless, because you can use services that use AI in making your own application. This can be anything starting from making websites that recognize people, websites that write automatic translations, like subtitles to what people are speaking in different languages. Even that previous example, websites that estimate prices of buildings. Maybe you want to sell your apartment and you have no idea how much to ask. You could go on a website that offers such a service. So applications are quite many. The reason why JavaScript is not primarily used for machine learning is that it's relatively slow. I mean, it runs in a browser or in these kind of environments like Node.js, and that doesn't take advantage of the full capability of what your computer, of what the hardware is capable of. So if you think about the training process, that part where the computer discovers the formula that it's going to use to predict something or generate something, that part is usually not done in JavaScript, because you want the process to be efficient. And some applications like this ChatGPT was trained for a year, constantly running machines, making its function to predict the next word or whatever better and better, and it uses a lot of resources. If you have to work in an environment that is half as fast, then you're going to spend 2 years. And that's where you really see the reason why JavaScript has not been like a popular method for implementing these functions. But it is driving the web, and these systems are usually on the back end. Or what you can also do is just load that formula. I mean, what you have processed on for a long time, that's the model that is going to do the prediction or classification or regression or whatever your task is. Load that after you have gotten it, and JavaScript can easily just call it. So you don't necessarily need internet to build a machine learning capable application. But because JavaScript is not that much in link with machine learning in general, you may have models that don't have an implementation. So you might have to write some implementation by yourself, and people don't usually do that. There are libraries like this TensorFlow is very popular in JavaScript, and it can do some of the things, but it's small what you could do in JavaScript compared to what you could do in other languages like Python, for example, which is not really, it is a fast language, and much of it has also C support, and it can be really fast. But the reason it became popular is because it's more of a researcher's tool. And people who do progress in machine learning typically like to implement some lightweight language like Python and try out solutions. But in the end, you still most likely end up taking that code and porting it into something low level if you are building something critical. Like a self-driving car system, you want it to react fast, not have an accident because it's too slow, because it's running JavaScript or Python or something like this. So, yeah, you could make any of these things. Anything that uses an app built with AI, you're golden with JavaScript. And I do teach a lot of AI with JavaScript, and I don't teach using APIs or using external code. My channel is mostly about building things without any libraries, because I just want to teach the people how things work, not how to get something done fast. And I have made different things like self-driving car simulations and drawing recognizers. I have this one course with learning about machine learning by making an app that recognizes what you're drawing. And I collected a bunch of drawings from YouTube viewers. I think I collected something like maybe at the moment 6,000-7,000 drawings from people, and that was my training data and also testing data, because I divided it half and half to have a way an evaluation, to do the evaluation. And that was a nice course because people were involved and they had some data points there. We collected the data together, and I was thinking that in this way people are more excited to follow the course. What is he gonna do with my drawing and things like that. And so pretty much any application that exists at the moment, you could have a web implementation of it, either by just calling some back API or doing what I do and implementing some of the functionalities from scratch. But in practice, people don't do that because these methods are relatively sophisticated and it's easy for you to make mistakes. So that's why people tend to use APIs and libraries that have been tested for a long time and that have a reputation behind them. So, it's not gonna glitch or anything like that. But the things I teach are somehow the simplest yet also most effective things that I could think of. So it's a good approach, I think, if you really want to learn why the things work. Because this is, I believe, the biggest issue with machine learning nowadays. You can make very sophisticated applications really easy, like use libraries, call a few lines of code, and you have a solution that does something like this drawing recognition. But you don't understand how that works. And the problem appears because you can't explain to your customer why it failed in some specific case. And you may not know that just behind the corner, tweaking the parameters a little bit, you could move from 70% accuracy to 98% accuracy. So if you just try a little bit and you get the idea that seems like it works and seems like you understand, you may be having problems with this. So a little knowledge, like in-depth knowledge about what these things are doing, can help a lot.
Gotcha. And as just one last question here before we wrap up, should developers be worried about AI taking all of our jobs? Or what do you kind of feel about that? I'm particularly curious about your opinion because I've asked this question to some other web developers, but they're not really in the kind of, AI, machine learning space, and I definitely think that you're much more in that space than anybody else I've asked. So I'd be very curious on kind of what you think about it.
There are so many variables here, like I was mentioning previously, that it's also hard for me to give a yes or no question, yes or no answer. But yes, I think that developer jobs will go down. And the reason why I say this is that often when meeting with people working at companies or CEOs at companies, they really wish that people would be skilled, like they would come out of university and they would have experience, maybe 5 years experience in work, and that's just not realistic. And many tasks at the moment you can give to things like ChatGPT or GitHub Copilot or things that do some automated code writing. And these are tasks that they handle well, and they are tasks that you would give to junior developers. The difference is that, well, junior developers take a week to answer or to make the solution because it takes time for them to figure out how to do it. And these systems, these AI systems, answer immediately. Both of them make mistakes, and you may have to deal with the answers and say again, okay, change it like this and change it like that. But again, the AI thing answers immediately. And the thing is, if you continue in this way of thinking and you don't have junior developers, then at some point you won't have senior developers anymore. So companies know that, and they do still hire junior developers, even though the seniors apparently got this great assistant, this great AI assistant there, helping even more than the junior developers do, some of them. I don't know. So in the end, the question is, do companies want to have less developers and pay more for these AI tools? Because eventually they probably will cost, at least the very good ones, more. And that starts to cost as well. Or do they want to increase their productivity? Because at the moment, I think it's pretty much same thing if you fire the junior developers and use these AI things instead. Like, the productivity stays the same, but if you have the combination of both, then your productivity is going to increase. So do companies want to stay at the same level but decrease the costs on employees, or do they want to increase their performance? And I suspect it's this one. So in this case, people shouldn't be worried about the jobs. But what I really think is that those kind of coding jobs are gonna slowly disappear, those easy to do coding jobs. In the same way that now when you write code, your editor is doing much of the work for you. It may complete functions for you, even without the AI part. You don't have to write the syntax perfectly. You just start the name of the function, it automatically makes it well. So the skill of being perfect at typing each individual character and remembering to close each curly brace is automatically done for you. These are skills that developers that started when I did really needed to know. And a lot of these bugs don't appear anymore because the editor, even before you compile, or in case of JavaScript, deploy the application, it tells you that something is wrong there, and it even shows you where something is wrong. So we are being assisted a lot, even though we maybe take it for granted now. That makes developers today much more capable than in my time, because you're assisted by your computer. It's not AI, or at least few people call it AI, but it is something that makes us very productive today. And you don't need to be like complete expert, and even you don't need to read documentation so much, because many IDEs, like I just did some C# a moment ago, and this Visual Studio application, like you type the name a dot after an object, and then you get all the possible methods, you get all the possible events that could be listed there, and their name is intuitive. So the IDE itself makes you such a good developer nowadays compared to what you were in the past. So in the same way, I think that AI is going to make you an even better developer. There is one key thing that AI will have trouble with, and that is being able to make a bridge between the customer and the programmer. Customers don't know what they want, and they don't know what is possible. And if they just start to write something to AI, they don't know what to ask for and how to get something that they want. So there is a human aspect that is going to be needed for a very long time. They just don't know how to ask. So the job of the programmers and the architects and people in companies first is to figure out what that customer wants and ask the right questions. And it's a human touch there.
Absolutely. And I think I feel, very similar. I think at least in the short term, it seems like AI is more of a productivity enhancer for developers, in which it can just kind of speed up their workflow a little bit and improve their efficiency. Over the long term, I do agree that it seems like where things are going, it could decrease the need for developers in the long term, especially in the sense of developers on a certain team or in a certain business. Like, instead of a startup needing to hire 5 developers in the future, they might just need 1 or 2. And, in general, across a bunch of different teams, that might decrease the need for overall developers. But I also think that in a lot of jobs and a lot of teams, the company would love to have more developers. It's just kind of constrained by the amount of resources they're willing to allocate to their engineering team. So on those teams, they would love to just have developers be 10 times more productive, and they would still keep all their developers on their team. So I think that it's hard to say. Like, I think right now, it definitely is going to increase productivity, but whether that actually material leads to less kind of developer jobs and stuff like that within the next, several years, it's kind of hard for me to say.
Yeah, humanity has went up like better and better at productivity. If you think about technology nowadays, it's so different from 10 years ago. And the only reason this happened is that companies were growing and people were getting more capable and so on. And now there could be a spike of productivity, so that the companies that don't get so much money, the companies that don't get so many products, may choose to become AI companies that work with few people. And that's really hard to predict how many of companies are in this situation. And it's interesting times, so to speak.
Yeah, for sure. And when IDEs came out and increased developer productivity, and different frameworks come out and increase productivity, it still feels like, to me anyways, the demand for developers and stuff like that is still quite high. So, it's hard to say. Maybe a developer's job in the future looks a little bit differently, but we still need someone with, that is really good at the tech stuff in a company. I think that's always going to be there. And I think developers would be well suited for, that sort of thing, whether that's actually writing the code themselves or just making sure that, like you said, that integration between figuring out what a customer wants and having someone kind of implement that in some sort of tech solution, whether that is writing the code themselves or just having, directing some AI to do it. I think there's still going to be someone that's going to be needed in that kind of middle ground, at least for a while here, depending on what other technologies are evolved from this. So
yeah, and robot-related applications are far away from becoming the futuristic stuff that we might think of. And like, if I make a an application that uses GPS or something like this. How do you test it if you don't have any people in your company? Everything is AI. You, as the CEO, have to go out and test and see what happens when the satellite is blocked by some bird or whatever. So there are always, how to say, I did mobile development for many years, and there are problems like maybe the beeping sound when you receive some notification is not good enough because you don't account for how the traffic is going to affect like the background noise. Or maybe it starts raining and then the buttons in your application are configured in such a way that the raindrops impact you pressing them in a very bad way. Like maybe you accidentally press the one that deletes all the data that you collected for some particular reason, just because the screen was wet. And of course, things like brightness, contrast, difference. How do you see this app in the sunlight? How do you see it in the shadow? The light sensor, does it affect the way you want it? So things that ChatGPT or related tools couldn't test. It's not just writing unit tests for it. And of course, these applications, I'm just giving now this mobile app, but a lot of things that have to do with monitoring heart rate or this sports tracking or delivery apps, routing apps. Did it give a proper route? Or did you end up going on a road that is blocked and you have to turn back? There is some testing. Of course, self-driving cars and these things. It's a lot of testing like this needs to be overseen by people because we don't have robots with nearly as good capabilities as we have. So all these applications that are emerging, things like robots, things that have to do with moving outdoors, I think they will be the things that we will focus on when coders don't have other jobs because these AI things can do them for you. So I wouldn't worry about it, but sure, some jobs will disappear. I'm confident that some companies will say we don't need so many people anymore and things like that. But other companies come and people go in other places and so on.
Absolutely. Well, with that, thank you for being so generous with your time here today. If people want to find your YouTube channel and find other content you're producing, where should they go for that?
I think it's just youtube.com/@Radu. So it's my name there.
Cool. And I will have that linked in the description here. But thank you so much for coming on today. I definitely, selfishly enjoyed it. And I learned a lot. So thank you so much.
See you.